Hi, we are students from the classroom 302 of CDEV, and we're here to show you an experiment we executed and the results we obtained. Before we start though, there are a few topics you should be familiar with to understand our explanations. We all know what gravity is, right? The force the earth uses to pull us back to the ground? Well, if you know that, then understanding free fall should be easier, which is just when you let something fall from a height and let gravity do all the work for you. Most of us remember this as the time we lost our ice cream when we were 5.
The ice cream.
So, thanks for that, gravity. Regardless, gravity does not pull you down at a constant rate. That will be velocity, which is just speed in a certain direction. No, gravity pulls you faster the longer you fall. This continuous increase in velocity is called acceleration, and in this experiment we're going to test this acceleration created by gravity using an inclined plane, a surface calibrated on one side. Come on, you should know this stuff. Anyways, let me now show you our experiment. So, after seeing all of his experiments, the results are kinda obvious, right? As you could have easily noticed, the ball doesn't move by itself. It is gravity who's bringing it down. But since the mass is located on an inclined surface, that vertical movement is also translated into a horizontal one. As we saw earlier, gravity does not make objects move at a constant speed though. It makes them accelerate over time. Hence, why the distant graphs show a curvature in the position of the object, and the velocity graphs a straight diagonal line. This acceleration in free fall would be of about 9.81 meters per second squared, but because the object is located on an inclined plane, its acceleration differs. Finally, and not so easy to answer question would be, does the mass of the marble affect its acceleration? Well, the answer is a bit tricky, but after a little bit of investigation and experimentation, we concluded that in this case, it does. But that is just due to the air resistance as an external factor. So there you have it, all questions have been answered, and we guided you through a deep dive into the inner workings of acceleration. We hope you understood everything we talked about and had fun while learning with us. We hope to see you around, and thank you for watching. Bye!